The idea of dropping weapons from the sky, a concept as old as warfare itself, predates powered flight, existing in the realm of imagination and theoretical possibility. But the airplane, with its newfound ability to soar above the battlefield, made it a reality, transforming the very nature of conflict. The bomber changed warfare, ushering in an era where the front lines were no longer the only targets, adding a new dimension, a vertical axis of attack that could bypass defenses and strike deep into enemy territory, reaching the heart of industrial production and civilian populations. It became a symbol of national power, a tangible representation of a nation's ability to project force, able to influence events far from home, shaping geopolitical landscapes and dictating the terms of engagement. Each new bomber aimed to fly higher, pushing the boundaries of altitude and challenging the limits of human endurance, faster, breaking the sound barrier and shrinking the world with unprecedented speed, and farther, capable of traversing continents and oceans, delivering their deadly cargo to any corner of the globe. Carrying ever more destructive payloads, from conventional explosives to the ultimate deterrent, nuclear weapons. Early bombers were vulnerable, fragile machines susceptible to enemy fire and the harsh realities of aerial combat, but the need to overcome defenses drove rapid innovation, spurring advancements in aircraft design, engine technology, and defensive armament. The bomber's evolution sparked a technological arms race, a relentless pursuit of aerial supremacy that reshaped global power, influencing international relations and defining the strategic landscape of the 20th and 21st centuries. Some bombers became legends, iconic aircraft etched into the collective memory, machines that defined eras and left a lasting mark on history, symbols of innovation, power, and the ever-present threat of aerial warfare. Among them, one stands out, a titan of the skies, as the most powerful and enduring strategic bomber ever built. Its story is one of engineering brilliance, a testament to human ingenuity and the relentless pursuit of technological advancement, political intrigue, and a legacy that spans more than 70 years, a period of unprecedented global change and conflict. This aircraft became synonymous with air power itself, a symbol of American might, and a key component of its strategic deterrent. It's a testament to a vision, a bold and ambitious plan to create a bomber capable of withstanding the test of time, that has kept it relevant for generations, adapting to evolving threats and remaining a vital asset in the modern military landscape. Today, we explore the story of this legendary machine, delving into its design, its history, and its enduring impact on the world. The journey of the world's most powerful bomber begins here. The story of the bomber begins with a single, daring act. The first aerial bombing took place in 1911, a moment that seems almost quaint by today's standards, but one that irrevocably altered the course of warfare. It was during the Italo-Turkish War when an Italian pilot, Giulio Gavotti, took to the skies and dropped grenades by hand onto Ottoman troops below. Imagine the scene: a fragile aircraft, a brave pilot, and the rudimentary beginnings of aerial bombardment. The damage inflicted was minimal, almost negligible in the grand scheme of things. However, this act set a huge precedent, a turning point in military strategy. It demonstrated the potential of aircraft as offensive weapons, forever changing the landscape of battle. World War I acted as a catalyst, rapidly advancing bomber technology at an unprecedented rate. The need for more effective ways to strike the enemy spurred innovation and development in aircraft design and weaponry. Early bombers were fragile biplanes, often constructed from wood and fabric. They carried small payloads, and their crews faced great danger from enemy fire and the inherent risks of early aviation. These brave airmen paved the way for future generations of bomber crews. In the interwar years, a new breed of visionaries emerged. These were the thinkers and designers who dared to imagine the future of aerial warfare. They argued that large fleets of bombers, strategically deployed, could cripple an enemy's infrastructure and ultimately win wars. This concept, known as strategic bombing, became a central tenet of military doctrine. The theory was that by systematically destroying key industrial sites from the air, a nation's ability to wage war could be neutralized, forcing a swift surrender. This belief fueled the development of more advanced aircraft, leading to the rise of metal monoplanes which were stronger, faster, and capable of carrying larger bomb loads. This era saw the birth of true strategic bombers, aircraft specifically designed for long-range missions and heavy payloads, such as the iconic B-52 Flying Fortress. World War II became the ultimate proving ground for these theories and technologies. The conflict witnessed the full-scale deployment of strategic bombing campaigns across Europe and the Pacific. Thousands of bombers flew in massive formations, delivering devastating blows to enemy targets. These raids were a testament to the scale and intensity of aerial warfare. The British Avro Lancaster, a heavy bomber known for its ability to carry massive payloads, and the American B-17 and B-24 redefined aerial warfare, demonstrating the power and reach of modern bomber aircraft. The B-29 Stratofortress, with its pressurized cabin, long range, and the capacity to carry atomic weapons, represented the pinnacle of bomber technology at the time. It marked the peak of piston-powered bombers, a testament to the ingenuity and engineering prowess of the era. The war ultimately proved that air superiority and strategic bombing were essential components for achieving victory, solidifying the bomber's place in modern military strategy. As World War II drew to a close, aviation technology leapt forward once again, ushering in the jet age and forever changing the landscape of aerial warfare. The next generation of bombers would be built not just for conventional warfare, but for a far more ominous purpose. Their primary mission would be to deliver atomic devastation across continents, holding the fate of the world in their bomb bays. The Cold War ignited a fierce race for the ultimate doomsday machine, pushing the boundaries of bomber technology to unprecedented levels. The bomber's role was forever changed, transformed from a tool of conventional warfare into a symbol of nuclear deterrence. The world would never look at air power the same way again, forever aware of its potential for both destruction and, paradoxically, the preservation of peace through the threat of mutually assured destruction. The ashes of World War II had barely cooled when a new global struggle began to take shape. The world, exhausted from years of conflict, now faced a different kind of threat. This was the Cold War, a tense standoff defined by the looming threat of nuclear arms and escalating global tension. The ideological battle between the United States and the Soviet Union permeated every corner of the globe, influencing political alliances and sparking proxy wars. In this new era of strategic calculation, the strategic bomber became the linchpin of nuclear deterrence. It represented the ultimate expression of power projection, a constant reminder of the devastating consequences of all-out war. These massive aircraft were able to deliver atomic weapons deep into enemy territory, holding entire nations hostage to the threat of annihilation. They were a symbol of both power and vulnerability. In the early years of the Cold War, the U.S. relied heavily on the B-29 Stratofortress, a relic of World War II, and the massive B-36 Peacemaker, a behemoth of the skies designed to carry the largest payloads over vast distances. But these were stopgaps, temporary solutions to a rapidly evolving threat. They were increasingly vulnerable and outdated in the face of advancing Soviet technology. The Soviets, determined to achieve parity, raced to catch up in the arms race. Initially they focused on copying American designs, but soon they were innovating with their own jet bombers, pushing the boundaries of aviation technology. The escalating Cold War made the need for a jet-powered intercontinental bomber paramount. This urgent requirement drove American innovation to new heights, spurring advancements in engine technology, aerodynamics, and materials science. The stakes were enormous, with the balance of global power hanging in the balance. The development of this aircraft would become the backbone of U.S. strategy for decades, shaping military doctrine and influencing international relations. It had to be reliable, capable of operating in extreme conditions and maintaining peak performance under immense pressure. It needed to be adaptable, able to evolve and incorporate new technologies to meet emerging threats. And it had to be powerful enough to guarantee national security, projecting American strength across the globe. The project demanded vast resources, requiring the collaboration of countless engineers, scientists, and manufacturers. It pushed engineering to its limits, forcing designers to overcome seemingly insurmountable challenges. The result would be an aircraft that exceeded all expectations, a testament to American ingenuity and determination. It would become the most iconic bomber in history, a symbol of American air power and technological prowess. The Cold War arms race had found its ultimate symbol, a machine that embodied the hopes and fears of an entire generation. The world was about to meet a true titan of the skies, an aircraft that would redefine the meaning of strategic bombing. The age of the strategic jet bomber had arrived, ushering in a new era of aerial warfare and global power projection. Creating the ultimate bomber required breakthroughs in jet engines, aerodynamics, and materials. The B-47 Stratojet's swept wings and podded engines set the standard for future bombers and airliners. Swept wings, inspired by German research, allowed higher speeds by delaying shockwaves near the speed of sound. Aerial refueling, perfected by the Strategic Air Command, gave bombers global reach. New aluminum alloys and advanced manufacturing enabled massive, strong airframes. These innovations, jet power, swept wings, refueling, and new materials, were the foundation. They made possible a bomber that could fly farther, faster, and higher than ever before. The stage was set for a legend. The world was ready for the B-52. In 1948, Boeing won the contract for America's next intercontinental bomber. A bold redesign led to the B-52 Stratofortress 8 jet engines, swept wings, and massive size. The prototype flew in 1952, revealing a giant with a 185-foot wingspan and a 5-story tail. Designed for high-altitude, long-range missions, the B-52 entered service in 1955 as the backbone of U.S. nuclear deterrence. For decades, B-52S stood ready to launch at a moment's notice, a constant symbol of Cold War power. Its adaptability set it apart. Originally a high-altitude nuclear bomber, it evolved for low-level penetration and conventional bombing. The B-52's ability to take on new roles ensured its longevity. It became a devastating force in conflicts like Vietnam and beyond. The B-52's story is one of reinvention and resilience. Its presence shaped global politics for generations. The legend of the Stratofortress was just beginning. The B-52's design is a masterclass in robust engineering. Its long, flexible wings provide lift for high-altitude flight and stability at low levels. Unique landing gear and 8 powerful engines give it unmatched range, over 8,800 miles unrefueled. With aerial refueling, its reach is global. The internal bomb bay and external pylons allow a 70,000-pound payload, everything from conventional bombs to nuclear weapons and cruise missiles. A 5-person crew operates in a 2-deck cockpit, with advanced systems continuously upgraded over decades. Modern avionics and communications keep the B-52 relevant on today's battlefield. Its versatility and endurance are unmatched. Boeing built 744 B-52S. Only the B-52H remains in service, with plans to fly into the 2050S, nearly a century of operation. In 1957, B-52S circled the globe non-stop, proving their reach. A single B-52 can carry more bombs than a Wadiway 2 heavy bomber did in its entire career. It's the only U.S. aircraft certified for every air-launched weapon, from gravity bombs to cruise missiles. The B-52 is cost-effective, outlasting and outworking newer, more expensive bombers. Its nickname, Buff, Big Ugly Fat Fellow, reflects its status as a beloved workhorse. The B-52 is a legend not just for its power but for its staying power. The B-52 is more than a machine, it's a cultural icon and a symbol of American might. Its silhouette is instantly recognizable, immortalized in films like Dr. Strangelove. The B-52's design influenced generations of jet aircraft, both military and civilian. As the backbone of nuclear deterrence, it helped prevent the Cold War from turning hot. Its greatest achievement may be that its power was never fully unleashed. Today, the B-52 continues to serve, modernized for new missions. It has outlasted its intended replacements and remains vital to U.S. air power. The B-52's legacy is one of adaptation, endurance, and unmatched influence. The B-52's power isn't just in speed or stealth. It's in payload, range, versatility, and strategic impact. No other bomber matches its combination of capacity, reach, and longevity. Designed for nuclear war, it adapted to every new era and mission. The B-52 is a paradox. A 1950s airframe with 21st century technology, still delivering global power. Its continued service is a tribute to its designers and the wisdom of keeping it flying. The B-52 stands alone as the most powerful and significant bomber ever built. It is a living legend, still writing its story in the skies. The B-52 Stratofortress, unmatched, unrivaled, and unforgettable.